Hello everyone, welcome to our introductory discussion for Chapter 7 of Management Information Systems, Managing the Digital Firm. This chapter we will briefly discuss telecommunications, the internet, and wireless technology. So let's begin. So our learning objectives for this chapter are: what are the principal components of telecommunication networks and key networking technologies? What are the different types of networks? How does the internet and internet technology work, and how do they support communication and e-business? And what are the principal technologies and standards for wireless networking? Now, this slide kind of discusses recent developments in networking technologies. So in the past, organizations basically use either telephone networks or computer networks for communication. We now basically use broadband technology or better for data communication. And so here we kind of get into what a network is, along with the components that you will find in a simple network. Now, a computer network is simply the connection of two or more computers. Each computer on the network contains a network interface, or NIC, a NIC, device to link the computers to the network via telephone wire, coaxial cable, radio signal like a cell phone or Wi-Fi networks. Now, network operating systems, or NOS, routes and manages communications on the network and coordinates network resources. They can reside on every computer on the network or primarily on a dedicated server computer. Then you have your hubs. Those are simple devices that connect network components by sending packets of data to all other connected devices. There's the switch, which is a little bit more sophisticated than a hub. It can actually filter and forward data to a specific destination on the network router. On the network. Routers. Routers are a communication processor that routes packets of data through different networks, ensuring it is sent to the correct address. And then you have the software-defined network or networking, or the SDN, which has one central program to manage the control function of switches and routers. Now, this slide looks at the additional components you might expect to find in a network of a large company that has many locations and maybe thousands of employees, right? So today's corporate network infrastructure is really a collection of many networks, from the public switch telephone network to the internet, to corporate local area networks or LANs, linking work groups, departments, or office floors, right? So now you have your LANs. So LANs are linked to other LANs, and firm-wide corporate networks are formed via powerful servers. You have your contemporary digital networks, and the internet are based on really three key technologies. You have client-server computing, packet switching, communication standards, or TCP/IP, which is transmission control protocol / internet protocol, right? So now this slide and the following two are basically going to take a look at the main technologies in use today for networks: client-server computing, packet switching, and TCP/IP. But I will say this: for the client-serving computer, I'm going to refer you back to Chapter 5 because we did discuss this in Chapter 5. So check out Chapter 5 for review, but we will discuss it in class or review. So here we're looking at the second, packet switching, right? Note that circuit switch networks were expensive and wasted available communication capacity. So the circuit basically had to be maintained whether data was being sent or not. So it is also important to note that packet switching enables packets to follow many different paths. So if one path is blocked due to an accident or power failure, the data will automatically be shifted to routers to open paths. However, in truly massive outages, like say the one that happened in New York on September 11th, 2011 on the World Trade Center, nearby, like the metropolitan servers that were close to that area were really knocked out, and for a period of several days, internet access was limited in the New York metropolitan area. Okay, so now packet switching is basically the method of slicing digital messages into parcels called packets, sending the packets along different communication paths as they become available, and then reassembling the packets once they arrive at their destination. It just makes efficient use of communication capacity of a network. Now, the third main networking technology in use today and looks at it's the TCP IP. So now note that in a network there are typically many different types of hardware and software components that need to work together to transmit and receive information. Different components in a network communicate with one another only by adhering to a common set of rules called protocols. In the past, many diverse proprietary and incompatible protocols often forced business firms to purchase computing and communication equipment from a single vendor. But today, corporate networks are increasingly using a single common worldwide standard called Transmission Control Protocol / Internet Protocol, or TCP/IP. It's actually basically a suite of protocols, the main ones of which is TCP/IP. There's a suite of them that can choose from, but this is the main one. This slide looks at the types of networks that organizations use. So a network can be defined by the way the client interacts. So it could be like a client server versus peer-to-peer, right? Or the type of physical medium to carry signals, whether it's Ethernet, fast Ethernet, etc., and the way in which computers are connected and send signals to each other, or the topology. Now this figure, you should find it in your book on page 257. But a modem is a device that translates digital signals into analog form, and vice versa, so that computers can transmit data over analog networks such as telephone and cable networks. So now this graphic actually illustrates the difference between digital and analog signals, right? And shows how digital signals can be sent to other computers over analog cables such as telephone and cable lines, which are analog. But note the difference. So note that the digital signals, though, actually work in binary, right? So it's binary digits of zeros and ones, which is like an on-off type of translation. And they're represented logically as on-off, like I said, electrical pulses. So that's pretty much it for the digital versus analog. Then you have transmission media and transmission speed. So this slide looks at the media involved in network transmission. Now note that many of the telephone systems in buildings had twisted wires installed before analog communication, but they can be used for digital communication as well. Also today, telecommunications companies are starting to bring fiber optic cable into the home for high-speed internet access. Now regarding the internet, one of the things that I want to bring to your attention is that the internet comprises many more services than just email and the web, right? The two that we basically we use it predominantly for. We see here we have email, chatting, instant messaging, news groups, telnet, FTP, VoIP as well. So let's discuss these a little bit. So now, if you are fortunate enough to have cable internet telephones, or if you have experienced a VoIP, where you're going to have cable internet telephones, or using the internet, cable internet as your telephone. That makes more sense if I say it that way. There are other popular technologies that use internet as a platform. Of course, there's VoIP, there's unified communications, there's virtual private networks, and we'll discuss those more as well in the classroom. Here, this figure I do believe is on page 270 in your book, but I can guarantee you it's in chapter 7 somewhere. So now this VPN is a private network of computers linked using a secure tunnel connection over the internet. It protects data transmitted over the public internet by encoding the data and wrapping it within the internet protocol. So by adding a wrapper around a network message to hide its content, organizations can really create a private connection that travels through the public internet. Now this graphic illustrates how a virtual private network, or VPN, works. The rectangles A, B, C, and D are they represent the different computers on the VPN. In a process called tunneling, packets of data are encrypted and wrapped inside IP packets. By adding this wrapper around the network message to hide its content, as I said previously. Now here we're discussing briefly the continuing revolution in wireless communication. So now most cell phone users today rely on 3G networks, a standard which first appeared in early 2000 and was improved upon over the last decade. Now 3G networks have mobile upload capacities of about 144 megabytes per second. Enough for email and some web browsing, but not videos. Now 4G networks started appearing in 2010 in the US. They are also called LTE, or long-term evolution networks. 4G cell networks can be used for display of video on mobile devices with download speeds of about 100 megabytes per second and upload speeds of about 50. Here we see the current standards in wireless networking, and one thing I'd like to point out is that in most Wi-Fi communications, wireless devices communicate with a wired LAN network using an access point. And we can discuss this a little more in class as well. Now this slide continues the discussion about wireless networking and Wi-Fi. So now note that wireless networks based on the upcoming 802.11n specification will solve interference problems by using multiple wireless antennas in tandem to transmit and receive data, and technology to coordinate multiple simultaneous radio signals. Here in this figure we see Bluetooth enables a variety of devices including cell phones, smartphones, wireless keyboards and mice, PCs and printers to interact wirelessly with each other within a small 30-foot or 10-meter area. In addition to the links shown on this figure, Bluetooth can be used to network similar devices to send data from one PC to another, for example, as well. Now, Something else I want you to notice about this graphic, it kind of illustrates the uses of Bluetooth for a PAN. So the Bluetooth connects the wireless keyboards and mice to the PC and cell phones to earpieces without wires. Bluetooth has the low power requirements, making it appropriate for battery-powered handheld computers and cell phones. Now, most cell phones today, of course, are Bluetooth enabled. A lot of things now today are really Bluetooth enabled, and it will allow the user to just connect to other wireless devices as well. Here we have the wireless LAN. Here in this figure we see a mobile laptop computers equipped with network interface cards linked to the wired LAN by communicating with the access point. The access point uses radio waves to transmit network signals from the wired network to the client adapters, which convert them to data that the mobile device can understand. So now the client adapter then transmits the data from the mobile device back to the access point, which forwards the data to the wired network. Now this graphic illustrates an 802.11 in wireless LAN operating in infrastructure mode that connects a small number of mobile devices to a larger wired LAN. Most wireless devices are client machines, so the servers that the mobile client stations need to use are on the wired LAN. The access point controls the wireless stations and acts as a bridge between the main wired LAN and the wireless LAN. So yeah. And last but not least, we have the wireless sensor networks, or the WSNs. It really is a basic introduction of an additional wireless technology having a major impact on business. Wireless sensor networks. Please note that the wireless sensors are linked into an interconnected network that routes the data to a computer for analysis. Is used to monitor building security, detect hazardous substances in the air, monitor environmental changes, traffic, or military activity. These devices have built-in processing, storage, and radio frequency sensors and antennas. They require low power, they have long-lasting batteries, and they're able to endure in the field basically without any maintenance. So that was a good introductory conversation regarding this chapter, Chapter 7. Until next time, have a great day, guys. Bye-bye.